Hi everyone, this is the IB Probability and Set Theory package, and we're going to take a look at the Explore related to conditional probability. Okay, conditional probability is kind of an interesting topic here. It's in a lot of cases when we talk about probabilities prior to this point, we're talking about entire populations. So we will know probabilities based on an entire population. Conditional probability kind of zooms us in a little bit. Okay, so we are going to have probabilities about the entire population. However, what we're interested in is a smaller section of the population and probabilities related to that. And you'll see what I mean as we go through this example right here. So the table below, I'm trying to make sure it's in the screen here. The table below shows the results of a survey which compares eye color and eyesight for 125 adults. So the table is incomplete, so we got to finish this table here. So, and it's easy enough to do here. So we're going to look at people with good eyesight. We got 31 that have blue eyes, 55 that have brown eyes. So together that is, what is that? That's 86. Now, just to make sure that we've got that correct here, because we've got totals here, we're just going to make sure that 86 and 39 is 125. Do the math in your head, and yeah, it is. That's 125. So that's good. Here we've got brown eyes. The total number of people that have brown eyes is 68. And so all we have to do here to figure out the number of them that have got bad eyesight is subtract. And that's going to be 13. Okay, and we'll just double check. Does that make sense? 26 and 13 and 39? Yep, we're good. And then the total number of people with blue eyes here that have good eyesight, bad eyesight altogether, you just add that down. It's going to be 57. And then again, just to double check here, does 57 and 68 give us 125? Yes, it does. So everything kind of works out. We're good. So the first step there was complete the table. We're done. Now, find the probability that a randomly selected person is blue-eyed. Now, notice there's no reference to whether they have good eyesight or bad eyesight. We don't really care. So blue eyes, the total number of people that have blue eyes is 57 out of 125. And that's really all we need to say here. Now I'm just going to double check and see if I can convert that to a nicer fraction, and I can. That's as good as it's going to get. Just wanted to double check that. Okay, good. Next question. Find the probability that a randomly selected blue-eyed person has bad eyesight. Okay, see, now what we're doing is we're starting to focus in on a smaller population out of the group, just the blue-eyed people. Okay, has bad eyesight. Let's take a look at the blue-eyed people. So out of those people, 26 of those blue-eyed people has bad eyesight. So that gives us 26 have bad eyesight out of 57 people. Okay? And so there we go. That's the probability of a blue-eyed person having bad eyesight. Next, find the probability that a randomly selected person has bad eyesight. Now, in this case right here, this is not focusing on a specific population of the group out of the whole total. This is just in general here. So what we want to do is take a look at bad eyesight. Well, how many people have bad eyesight? If we don't care about blue eyes or brown eyes, well, that's 39 out of that total of 125. So 39 out of 125. Now, down here, find the probability that a randomly selected person with bad eyesight has brown eyes. Okay? Now you got to be really careful when you read these things. Okay, what is the population that we're looking at here? Is it the population of people with bad eyesight, or is it the population of people with brown eyes? What's the sample space? That's the way you want to think of these questions here. Find the probability that a randomly selected person with bad eyesight. Okay, so this is the given in this question, the bad eyesight. That is the sample space. So we're going to look up here, bad eyesight. Well, there are 39 people with bad eyesight. Okay, we are looking at the group of them that have brown eyes. Okay, so here we go. So now we can go look at our chart here, brown-eyed people. So bad eyesight, 39, and we've got 13 of them. So that is 13 out of 39, and actually in this particular case here, I can finally reduce that a little bit to get 1/3. And so that's how conditional probability works here. When you start to zero in on a small group of the population, you really do have to focus and determine for yourself beforehand, what's the sample space? What's the group that we're working with?